Hi, this is Cole from Newton, and today we're going to learn about writing an exponential function from a description. Here we're given the description of an exponential function, and we're asked to write its equation. We're told f of x equals e to the x is shifted up 4 units, is stretched vertically by a factor of 2, and is reflected across the x-axis. We want to write the new equation g of x. So in this description, we're given the base function, f of x equals e to the x, and we're given several transformations that is done to this base function. We're told it's shifted up, told that it's stretched vertically, and we're told that it's reflected. So each of these transformations will correspond to a term in the general form of the equation for an exponential function. So here we have f of x equals a times b to the x plus c plus d. Now the terms a, c, and d will correspond to specific transformations done to the base function b of x. In our example, b is e. So let's first look at shifting vertically. So if a function is shifted vertically, that's shown with the d term. A function is shifted up if d is positive, and a function is shifted down if d is negative. We can see that in the graph here. We have our base function, f of x equals e to the x, and then we have these two shifted functions. H of x is shifted up by 2 units, so it has d equals positive 2. We have e to the x plus 2. G of x is shifted down 2 units, so we have d equals negative 2. Next, we can look at shifting horizontally. Now a function is shifted horizontally by c units, and we have our c term is in the exponent. So we have b to the x plus c. Now this is kind of confusing because the function is shifted left if c is positive, and the function is shifted right if c is negative, which is a little bit counterintuitive to what you might think on a graph, because typically the positive x direction is to the right. But in this case, if it's shifted right, c is negative. And we can see that on the graph here. We have our base function, e to the x, and then we have our function that's shifted left, h of x, which has a c value of positive 2, so shifting left, positive c value. And then we have g to the x, which is shifted right by 2 units. So we have c equals negative 2. Shifting right, negative c value. Now in addition to shifting, we can also stretch and compress the graph. So the function is stretched if the absolute value of a is greater than 0. And the function is compressed if the absolute value of a is between 0 and 1. So if we have an a value of 10, it's going to stretch the graph. But if we have an a value of 1/10, it's going to compress the graph. And that's shown by the coefficient a, which comes before the b to the x term. Now we can see some stretched and compressed graphs here. So we have our base function e to the x, and then we have a stretched function, g equals 3e to the x. You can see how it's been stretched up slightly. And then we have our compressed function, h of x equals 1/3 e to the x, and we can see how that's been compressed slightly. Next, the a coefficient also tells us if the graph is reflected. So the function is reflected across the x-axis if a is less than 0. If a is positive, then it's not reflected at all. So we can see a reflected function here. So we have f of x equals e to the x, it's our normal base, and then we have h of x equals negative e to the x. And we can see that it's reflected across the x-axis. We can also reflect across the y-axis, oops, typo, and we see that this is done by making the x term negative. So if we have a to the b to the x and we want to reflect it across the y-axis, we would write a times b to the negative x. We can see that in the graph here. Oh, did it go? There we go. So here we have our base function, f of x equals e to the x, and we have our reflected function, h of x equals e to the negative x. So notice that the x term in this case has a negative sign in front of it, and the x term in this case does not. So now that we know all of these transformations, we can go back and look at our original problem. So we're told that f of x equals e to the x is shifted up 4 units. Okay, so that tells us that d equals positive 4. We're told that it's stretched vertically by a factor of 2. Okay, so the absolute value of a is going to be 2. And then we're told that it is reflected across the x-axis. So that means that we're going to have a negative a. So our a value must be negative 2. Now we're not told that it's shifted horizontally at all, so we know that c equals 0. Now that we have all of our terms, we can write the new equation g of x. And now g of x equals negative 2 e to the x plus 4. Forgive my sloppy handwriting. And that is our solution.